Good morning. Welcome to the Machine Learning No Expertise Required track at the AWS Machine Learning Summit 2021. In this session, I'm going to walk you through how to set up your own intelligent document processing pipeline with AWS Machine Learning Services. My name is Prem Ranga, and I'm part of our machine learning and AI practice here at AWS. I'm a senior solutions architect, and I love helping our customers help them adopt machine learning and AI services with AWS. So today we're going to walk through how to set up your own intelligent document processing pipeline. But before we get there, let's first talk about what are some of the common challenges that our customers face with setting up document management workflows, and why, in that context, a cloud based machine learning solution is important. And then we will introduce a few AWS machine learning services that we have used in this demonstration to set up a document management workflow. We will then talk about the use case itself and walk you through an architecture, followed by a demo. And finally, we'll talk about some resources that you can use to get started and try to do the solution on your own. All right. So let's talk about some of the common document management challenges our customers face. Enterprises, small to medium to large enterprises, have tons and tons of documents that they receive on an ongoing basis. And these documents, as part of their operational processes, some of these documents will have to be processed real time or near real time as soon as they come in. And some of these documents will have to be processed in bulk or in batches, for example, as a nightly job. And if you look at what these documents are, they have varied formats. So some documents may be PDF documents, some of them may be JPEG or PNG. And if you look at what these documents represent, they may be invoices or receipts or expense forms or application forms. And maybe sometimes it may be technical specs and so on. Now, if you look at what's contained within those documents, it's of diverse content. So for example, you have text which is printed, you have text which is handwritten, you have text that's contained in paragraphs and words and lines, or text that's contained in tables, as well as text in key value pairs. And sometimes text can be of multiple languages as well. Now, and if you look at what are the needs that customers or organizations have to process these documents, because they use the content in them for a variety of purposes. For example, they may use it for, let's say, filling up their knowledge management repository or content management repository. They may use it for running some predictive analytics to gain strategic insights. They may use it as a content that they input for their chatbots, or they may also use it for their operational needs as part of their processing workflows. So in that case, they'll store it into a data store, and then it's consumed by the downstream applications. Now, considering that this is the context, traditionally, customers have tried to solve this problem in a variety of different ways. And that's why I wanted to introduce why a cloud-based machine learning solution is important. Some customers have tried a manual workflow where they have teams of data entry operators that use applications and they look at, manually scan the documents, read the documents, take it field by field, and enter into the data entry applications. And you need to have a team of experts to train these teams of data entry operators, because the experts understand the document and the business context of these documents and the content better. So they'll have to train the data entry operators. Now, this is all good when you initially start it up, but as your organization grows and as your business needs evolve, you'll see that you'll have the document volumes will increase, the document templates and formats and structures will change, will evolve, and that means that you'll have to scale your teams. You have to scale your team of experts, and this is an inefficient and a cost-prohibitive process. Some customers have used rule-based optical character recognition software to solve for this document management workflow. And you see that these rule-based OCR, or optical character recognition software, you will have to define templates, and you'll have to define business rules of how to read document templates. And the templates and the rules are unique or specific for the document that you're trying to read. As the document changes, you'll have to keep updating the templates and the rules. And again, when organizations grow and the number of documents increase and then they consolidate their businesses, these templates will change, which means it's going to be a huge maintenance overhead to try to maintain these templates and the rules. And finally, if you look at the infrastructure that you need to spin up, to scale up your operational needs, to process large volumes of documents, maybe during peak demands, and then scale it down. If you look at a traditional data center type infrastructure, it's going to be difficult to do that, and it's also going to be cost prohibitive. So in the case of using machine learning for solving for the document management workflow, you don't have to worry about templates or business rules, because machine learning has got ready-made intelligence and it can automatically read textual content from your documents. And in the case of infrastructure, cloud is important because cloud offers elasticity. You can scale up or scale down your infrastructure based on your demand. And so that solves for the challenges that you'll have with the traditional infrastructure. Right. Now that we have talked about it, let's go to the next slide. Right. So I just wanted to quickly show you this quote by this famous linguist. So you shall know a word by the company it keeps, very similar to you shall know a person by the friends they have. So basically, this talks about the fact that natural language processing, or NLP algorithms, so these are a family of algorithms which use, let's say, the neighboring words to predict a word in the center, or use the word in the center to predict the words surrounding it. And it's a common technique for deriving text-based insights. And so we use natural language processing for one of our AI services called Amazon Comprehend, that we're going to introduce shortly, as well as we have used that in our demonstration. So we'll talk about that. Okay. So how does AWS machine learning services help with our document management workflow? With AWS ML services, especially at the AI layer, which is the top layer of our machine learning stack, we have services such as Amazon Textract and Amazon Comprehend, using which you can process millions of documents in minutes. And these services come with pre-built machine learning models with ready-made intelligence. So you can get started with using these services directly without needing any expertise or without having to train your own machine learning models. So what that means is we provide APIs, application programming interfaces, and all you have to do is call the API, pass your document, and then the contents of the document is extracted and it's provided back to you. Behind these APIs, we have powerful machine learning models that have been pre-trained to work with a variety of documents. Right. So Amazon Textract is used for extraction of text from documents. Amazon Comprehend is used to gain strategic insights from text based on analyzing the textual content to determine relationships between words and text, to determine context, to understand the sentiment of text, to understand the language of text, and so on. So there are a number of use cases for Amazon Comprehend. And finally, I'm also introducing Amazon Augmented AI as part of this use case, which is an optional step. But in our demo, we're going to show you how to use Amazon Augmented AI, or A2I, to set up a human review workflow for your machine learning application. So you can easily integrate a human team into your machine learning pipeline, and this team can review the predictions from your machine learning models. They can audit it. They can also make recommendations and changes to the prediction, which can be fed back to your models so that your models can learn from that feedback, so that you have created an intelligent machine learning workflow that learns from every document that it reads. Right. With that, I'm going to introduce you the demo solution architecture. So we call it the intelligent document processing pipeline or workflow. And so I'm going to demonstrate this to you shortly. But if you look at the architecture, so what it contains is we have set up an S3 bucket where you can upload a sample document that I have provided as part of this solution. And to this S3 bucket, I've attached AWS Lambda, which is our serverless compute service solution. And this AWS Lambda trigger will wake up as soon as a document is received, and it will call Amazon TextRacks API to extract the contents of this document. And subsequently, it will take that extracted content and it will call a Comprehend API, Amazon Comprehend API, which is trained to recognize entities from this textual content. And what we'll then do as part of the solution is, so we will take these entities and we will send it to a augmented AI human review loop. We will review the entities and determine if all the entities that needs to be recognized from the input document have indeed been recognized, and they'll make modifications to it or updates to it as required. We will then take these updated incremental entities that the human loop has identified and feed that back into the Amazon Comprehend model. And we will retrain the model so that it's able to recognize those entities in the next set of documents it receives. So that way, we have set up an intelligent document processing pipeline, whose intelligence evolves as it reads more and more documents. So that's what we're going to demonstrate in the solution. What you can also do, so when you try the solution, you can also take a look at the output from Amazon Augmented AI, which is a JSON output, and you can read the contents of that output and send it to, for example, DynamoDB database or a relational data store, and store it there along with the contents of your input document. So you can, which can then be consumed by downstream systems if they want to make some predictions based, or if they want to make some decisions based on the predictions from the machine learning model. So that's one way of continuing to build on top of this use case. All right. So before we actually jump into the solution demo, I'm going to quickly walk you through some APIs that we have used in the solution. So if you look at the tables that you see on the slide, so we have a few API examples for TextRack and a few API examples for Comprehend. So with TextRack, so all you have to do is you have to use the Boto3 if you're using Python, the Boto3 SDK, which is our Python API for all of our AWS services. You just pass TextRack to it, and you'll be able to get a handle to the TextRack service. The Analyze Document API call allows you to analyze a document in real time. So you pass, let's say, an image of a document, a JPEG file or a PNG file, and it'll, or you can just refer to it to an S3 location where the document is situated. And you're able to call this API, and this will run the machine learning model on that input document, and it'll give you the extracted content. And you can also, so this is a real-time usage of the API. If you want to use this API in batch mode, you can use the Get Document Analysis API. And then if you look at Amazon Comprehend, so we have a couple of examples that we have provided here. Of course, please do refer to our documentation if you want to look at more examples of how to use APIs with Comprehend. But you can detect entities, you can detect relationships in text, you can detect the sentiment of text, you can detect, for example, grammar as well as the language that the text is comprised of. Yeah, so these are some of the API usage examples. So in the demo, I will walk you through some more APIs that we will use for the purpose of the demo itself. And you can understand how to set up your own solution. All right. With that, let me move on to the next slide. Yeah, so this is where we will do the demo. If you see that bit.ly link I've provided there, that contains a link to the GitHub repository that I've created specifically for this Machine Learning Summit. Please go there. It contains all the code and some instructions on how to set up the demo on your own. And you can use that to get started. And subsequently, you can build on top of that for your own specific requirement. Please do give it a try, and please let me know how it went, and I'll be happy to know your feedback, and also happy to help you out in any way I can. All right, now let's get started with the demo. The first step is to take that link, bit.ly link I provided in the solution demo slide. And when you go to that link, you'll come to this GitHub page for the demo. And I provided all the steps here for you to try the demo yourself. The first step is prerequisites, where we will create the S3 bucket and we will clone our repo locally and we'll copy our files that we need for the demo to the S3 bucket. So that's the first step. So I completed the git clone step. So I went and created a folder, submit demo, did a git clone right here. And after the cloning, I logged into the folder, Amazon Text Track Comprehend. And here I have the list of directories that I need. So here I'll be going into ML Summit 2021. So it's going to be CD, ML. Let's see. All right. Yep. So these are the folders that we need for the demo. Okay. Prior to the creation of your CloudFormation template, and in fact, even prior to uploading your code to your S3 bucket, you need to modify the template to make sure that you provide the S3 bucket name that's going to contain your Lambda functions. So I know that I'm going to create a S3 bucket called MLS21-intelligent-code. So I'm going to go and modify my YAML file before I upload that to the S3 bucket. So let's do that now. Go here. So go to it's within the ML Summit 21 code, YAML file. Go here. Here, let me search for code URI. So 5 entries. There you go. So here, go and change the bucket name to the bucket name you're going to create. That's going to contain your code. So I'm going to copy this. For the data wrangler layer, which is also something that you need to change, instead of code URI, it's called content URI. So make sure that you remember to change this as well. Go ahead and change bucket name. Finally, file, save. So as per the prerequisites, I created the bucket and uploaded the folders into the specific prefixes within the bucket. So let's browse through that now. So I created a bucket called MS21 intelligent code. So if I click on this bucket name, you see I have two prefixes here, code, intelligent doc demo. So let's go into the code one first, code. And within code, I've got my CloudFormation template. This is what we're going to run in the next step or the next couple of steps. And then I have the Lambda handlers prefix. So if I go within that, I've got all my Lambda functions that we're going to use for the demo, along with the Lambda layer that contains some helper classes for us to set up a pandas data frame. Now, if I go back to the bucket, I've also got the intelligent doc demo prefix. So if I click on this one, I've got two prefixes, A to Y output and comprehend data. So comprehend data contains the training data set, which is this one, and then the list of entities file that contains all the entities that we'll be using for the demo. Which the comprehend custom entity recognizer will be trained on. And then if I come back and I look at the A2I output folder, it's currently empty. The reason is, so this output folder will contain the results from A2I as we run our demo, and we'll be using it later. The next step is to create a human review workflow for Amazon Augmented AI, which is a key component of our solution. First step, we'll create a private workforce, and we'll add some workers to the private workforce. Then we will use our UI task template that we have provided along with the in the GitHub repo for the demo for the solution. We'll use that to set up a custom worker template. And finally, we'll create a flow definition. And finally, after that, we're going to train a comprehend custom entity model. So we'll look at both of these tasks step by step. created a private team. So we added the worker. We're going to create a task template. Custom. Template has been created successfully. Now we'll create a workflow, flow definition. So our workflow has been created. Now we will train comprehend custom entity recognizer. Two entities we are training for: genuine, fake. It refers to whether the loan applicant is a genuine applicant or a fake applicant. Use entity list and training docs. Provide the S3 bucket name of where our files are present. Just copy the S3 URI. And provide it here. Change this to raw_text. Create a new IAM role. S3 bucket. Suffix, call it as MLS 21. Comprehend. We will resume once the training completes. Okay, our entity recognizer has successfully trained. So now we'll go ahead and spin up the CloudFormation template. Now that we have trained the comprehend custom entity model, let's have a look at the next steps. And so what are the parameters for the CloudFormation template? So we provide an input bucket, an output bucket name. So the CloudFormation template will create this for you. We provide the ARN of the flow definition that we created as part of the prerequisites. We provide the ARN of the custom entity recognizer that is being trained currently. And then we provide the S3 URIs of the entity list and the training dataset that we use for training comprehend. Once we provide these parameters, we can spin up the CloudFormation template. Stack. For this, we need the S3 URL of the CloudFormation template. So let's go there. So this is the template. Copy the object URL. Click next. So this is where we enter the parameters. So we'll start provisioning the stack. Go ahead and click next. Create stack. Create in progress. All right, the CloudFormation stack has been successfully created. Let's see what resources it has spun up. All right, so as you can see, we have some Lambda functions. We have some IAM roles. We have some systems manager parameters that we need for the solution. We also have some CloudWatch events roles, as well as the S3 buckets that we need. So as a first step, we have this Lambda function called textrat comprehend Lambda that will be notified as soon as we upload a loan application document into our input S3 bucket, the intelligent in bucket. So let's go and see how that's triggered. So if I go into my Lambda function, as you can see here, I've got S3 trigger attached. So if I click on that, so this is the bucket that we created. And it says as soon as I put a PNG file of the loan application in the intelligent doc demo input folder, it's going to trigger this Lambda function. So that's how we're going to kickstart this workflow. Now we're going to look at the input document that we're going to upload to our input S3 bucket, which is our loan application form. So it's present in this folder, ML Summit 2021, and with an input. So double click on this, open the PNG file here. So it's got borrower information, so just what we're using for the demo. Now it's got some personally identifiable information. So in this demo, we haven't included the comprehend PII feature, but if you'd like to add it as part of your workflow, so you can use the Amazon comprehend PII entities API. Now we're going to create the prefix and upload our input document. So our Lambda function told us that the trigger will happen when we have the prefix intelligent doc demo input. Create folder within this. Okay, I will upload the document. So this is present within the ML Summit 2021 input. Document is uploaded. So as soon as we uploaded the document, the Lambda functions created a folder, CER input. So this is the input folder that contains the CSV file that will be sent to the comprehend custom entity recognizer we trained for detecting the entities. So that CR input file has been generated. So now we should have a job that's running in comprehend for entity detection. So let's go and check that out. Now this is jobs. Right, so we see a custom entity recognition job, which is in progress. Very good. Our comprehend custom entity recognition job has completed. So this should have looked at the input contents of the document, detected entities, and this should be stored in our bucket as an output. Let's go and look at that. So we will now go into the out bucket. A prefix was created for us. A CR output prefix also has been created for us. And within this, we've got this folder that contains the star.gz file, and this file contains the results from comprehend. Our Lambda function has already extracted this and taken the relevant content that we need, and it should have stored this in our input bucket. So let's go and look at that as well. And here our output folder has been created. This is what we will send to our Amazon Augmented AI UI. So let's see that as a next step. The next step is for us to go and look at our labeling UI URL, login, and review the predictions from comprehend custom entity recognizer, make changes to it, and submit. So let's do that now. So this is our A2I UI, and we have a task that's waiting for us. So let's say start working. So these are all the contents from our input document. These are the entities that comprehend has already identified. So it says that these entities are all genuine according to comprehend. So let's go and make whatever changes we want to make. So I'm going to mark this and say that this is a fake. And I'm going to say that this looks genuine to me. And I'm going to say that the date of birth is a fake. All right, so we have done that. Let's go ahead and click submit. Okay, now that we have submitted our A2I task, let's go and see the results.
So if you recollect, we created a first bucket where we uploaded the code, and we also created a A2I output folder in that bucket. So the results of the A2I job and the JSON annotation that it produced will be in this folder. So we are here, A2I output. There you go. This is the output from A2I. Now, let's also look at the comprehend data folder. So in this folder, we originally uploaded entity list and raw text.csv files. If you recollect, we made some changes in the A2I task UI. So the changes that we made in the task UI recognized some new entities from the input document. And as a result, an updated entity list has been created to include those new entities. So as a next step in the process, what will happen is we will retrain the comprehend custom entity recognizer. So once the custom entity recognizer is retrained, the ARN of the new entity recognizer will be used for any new documents that come in. And this way, this is a continuous feedback loop, which will make the custom entity recognizer recognize your documents with a higher confidence as you run this continuously. Now that the entity list has been updated, I also wanted to show you this new entity check lambda function. So this new entity check lambda function is scheduled to be triggered by CloudWatch event, which is actually a scheduler that says it will be triggered once every day. So typically in the evening. Now, since we don't want to wait until then to show you how it works, I'm going to execute it right now so that we can see what happens as part of that process. So let's go to a test, practice code. Let's say test. So it says latest entity files loaded, new entities found, retraining the model. Let's go and check that out and comprehend what's happening. So you can see a new custom entity recognizer job has been submitted for these two entities. So which means that comprehend custom entity recognizer is being retrained with the latest entities that was received. As a next step in your workflow, when you implement the solution, you can specify that the entities that were found by A2I as part of the human loop be sent along with the contents of the original document to, let's say, a DynamoDB table so that you can then use it for downstream processing. So that will be a logical next step to the solution. So have fun experimenting. That concludes our demo. Thank you.
All right. So I hope you had as much fun watching the demo as I had creating it. Once again, you can use the bit.ly link that I spoke to you about to build this on your own and build on top of it for your use case. And in this slide, I've given you some additional resources. For example, if you want to look at a variety of ways in which you can use Textract for your own needs, please do refer to the GitHub Textract code samples. The pricing information for our services provided that. And I've included some blog posts. So this blog post, the intelligent document processing blog post right here. So this is the original inspiration for the solution I created for the summit. So please do read the blog post, provides you some additional context on how we can build the solution. But yeah, I mean, happy experimenting. And then I want to finish off with the slide here. So, so the learning doesn't stop by just watching these videos and trying this demo. If you want to continue learning, I would recommend to go to our AWS training and certification site. I provided the links in the slide, where we have more than 65 free digital learning courses for you to get started with not only machine learning, but also a variety of other AWS services that you will use as part of your machine learning workflow. You can also, we also have provided in this slide some links to resources that can help you preparing for your machine learning specialty certification. So this is a very popular certification. So please use this link to prepare for the machine learning specialty. You'll learn a lot as part of that process. But once again, if you need any help, or any if you want to share some feedback, please do feel free to reach out to us. And with that, I conclude my session. Thank you very much for being with me today.